Welcome back. We're looking at number 10 in our review packet on the next page, where we're using the periodic table to answer the name of the element, classify it as a metal, nonmetal, or a metalloid, determine the number of valence electrons present in its outermost shell, so not the total electrons like the last problem, just the outside, and finally the abbreviated or noble gas core electron configuration. Alright, so let's take it in order. Calcium here, whoops, kind of gave it away, is calcium, obviously. So Ca is calcium. Calcium is an alkaline earth metal, so it is definitely a metal. Valence electrons, so let's find calcium on our periodic table again. It is in group 2A, therefore 2 valence electrons. Abbreviated electron configuration, well, if you've forgotten how to do that, it's pretty simple. We find calcium. It's in the 4th energy level, or the 4th shell. The noble gas core is the noble gas in the 3rd period, which if we scroll over, happens to be argon. So I take argon's symbol and I write it in these square brackets, like so. And then I continue to calcium. So if argon has 18 electrons over here, calcium has 20 electrons. It's in the S block. So we say argon 4s2 because it's 2 positions into the 4s. So argon 4s2. And remember that 2 is a superscript. Moving down to selenium. Well, I'm just giving away the names. Se is selenium. Alright, we look up selenium on our periodic table. And if we're looking at this, this is... Here's the staircase on this one. It's not drawn in, so let me do that real quickly to make our lives simpler. Alright, so remember, elements which touch the staircase, except for aluminum, are metalloids. So if we remove aluminum, boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and sometimes astatine, depending on who you're talking to, are the metalloids. Selenium is over here. It is a non-metal. Wasn't quite touching it. Valence electrons. So again, I just realized I was off the screen. Apologies. Selenium is over here. It is in the oxygen family, sometimes called the chalcogens, but that's not really a name you need to know. It is group 16 or 6A, therefore it has 6 valence electrons. Abbreviated electron configuration. Well, selenium is down here in the 4th period, or the 4th energy level. So again, it's an argon core. So brackets, argon. We're going from argon with 18 electrons to selenium with 34 electrons. So I'm going to do this on the periodic table and I'll go back and write it in. So we say argon 4s2, 3, because remember we drop back, 3d10, we go over 10 positions, and then we go back to the 4th shell, or energy level, 4p, 1, 2, 3, 4. 4p4. So selenium is argon, 4s2, 3d10, 4p4. And that's the abbreviated electronic configuration. Alright, Zn, zinc. We look up zinc on the periodic table. It is in the transition metals. That makes our life easy. It is definitely a metal. Valence electrons. Well, if a transition metal, it gets a little bit tricky what we're calling a valence electron, but there's a quick little rule that you can try and remember. When we drop back an energy level, we're burying all of these electrons. So all of these 3d electrons that zinc has do not show in the valence level because this is the 3rd level, okay, 3d. These are in the 4th level. Even though they come before it, they're outside. So there's 2 for energy level 4 electrons. Those are what get counted as valence electrons. It has 2 of them. This is why zinc likes to make only a +2 ion. Okay, it doesn't work quite as neatly for a lot of the transition metals, but it's a quick and simple way to think about it. Alright, so again, noble gas core is argon, because that's the one before it. Move back over, 4s2. And then zinc is 10 positions into the 3D block. It's a full sublevel, so 3D 10. Argon 4s2, 3D 10. Fluorine, okay, a nice small one. Tricky to spell sometimes, comes from Latin. Fluor, fun little fact, means river. It is definitely a nonmetal. Valence electrons, well, it's king of the halogens, so it has 7, 1 short of that happy octet. And then our noble gas core configuration, well, fluorine is the 2nd energy level, so there's almost no point in doing this. We can just shave off a mere 2 electrons, but let's do it anyway. It's helium core, and then 2s2, 2p5. Helium, 2s2, 2p5. Alright, potassium. We're going back to the alkali metals. Potassium is a metal. It is an alkali metal in group 1, so it has 1 valence electron. And to do our abbreviated electronic configuration, again, it's a 4th shell element, so 3rd shell noble gas, argon. And then 4s, it's only 1 position in, so it's 4s1. Argon, 4s1. Final element, silicon. Si is a metalloid, a very common metalloid that we use to create integrated circuitry. It is in the carbon family, directly under carbon, so it has 4 valence electrons. It's in that group that's wishy-washy about forming ions. It could, but it likes to also do covalent bonding. Silicon's abbreviated configuration, because it's in the 3rd period, is neon 3s2, 3p4. So let's go ahead and write this out. It is neon 3s2, 3p2. I think I might have said 3p4 a second ago and gone all the way to sulfur for some reason, but we were actually doing silicon. It's only 2 positions into the p block. So neon 3s2, 3p2. Tune in for the next video to go through problem number 11.